This is a Lab 7 pre-lab video, some mean distributions, the sampling distribution of the sample mean. Before you attend this lab, read pages 51 through 56 in the lab manual. From lecture, you need to remember the following. Sampling distributions study what values the sample statistics can take for samples of a particular size. When we study quantitative variables, we study the sample means. The sample means can be thought of as random variables because the values randomly selected from the population can result in different sample means. We do know the following about sampling distributions of the sample means. We know that they are approximately normally distributed when at least the sample size is at least 30, or if the data was approximately normally distributed to begin with, the central limit theorem. The mean of all sample means will be the population mean. We also know that the standard error, which is a standard deviation of the statistics, can be calculated by taking the standard deviation of the population and divided by the square root of n. You can let the sample size vary when you study sampling distributions. If the sample size increases, the mean of the sampling distribution will remain the same. It will still be the population mean. However, the standard error will decrease as your sample size increases. If your sample size decreases, then again the mean of the sampling distribution will not change, but the standard error will increase. For example, this histogram shows what a Poisson distribution looks like. Note that the x-axis represents the values x takes, what the data itself looks like. So this is a data distribution. This histogram shows what the sample means for a sample of size 2 from the Poisson distribution looks like. What you should notice here is that the x-axis now represents the values of what the sample means of size 2 take, and that this distribution is still right skewed, but the peak is moving more towards the center than the data itself. And our last histogram shows what the sample means for a sample of size 30 from the Poisson distribution looks like. What you should notice here is that the x-axis again represents the sample means. The distribution is almost normally distributed. The central limit theorem says if n is at least 30, the sampling distribution is approximately normal. What you're going to do in this lab is repeat these steps for multiple different distributions. You will look at what the data itself looks like in a histogram and make comments on it. Then you will calculate sample means of different sample sizes, 2 and 30, and you will look at what the sample means, no longer the data itself, but what do their sample means look like. And you should notice that as you increase your sample size up to 30, your distribution of the sampling distribution will approach a normal shape. This is illustrating the central limit theorem using simulations. There are a lot of graphs in this. Make sure that you label everything carefully and you keep up with what each histogram represents. Also, on the last histogram, notice that the standard deviation for what the sample means are is much smaller than the second graph. The second graph, my sample means went from 0 to 5, and now they're from 0.6 to 1.8. Remember, the error, the standard deviation, decreases as your sample size gets smaller. Don't forget to take your pre-lab quiz.